In 9.3, we're going to learn how to solve quadratic equations by graphing. So first, I'm going to take this quadratic function and rewrite it as x squared minus 6x plus 5 equal to 0. And now I'm going to look for the axis of symmetry. Which is 3. And now I'm going to look for the vertex. So you have a vertex of 3 and negative 4. Now I'm going to look for the y-intercept. So it's at 5. I'm going to find a reflecting point. So there's 3 units here, so I need to reflect another 3 units to the right. And now I'm going to connect my dots. So the points in which the quadratic function crosses on the x-axis are your solutions of the quadratic function, or in other words, the zeros of the function. We can also solve this by factoring. So when y is 0, in this case y is 0, x is 1 and 5. So these are your solutions of the quadratic function. Just to add to this lesson, you can actually first factor and find the zeros, meaning where the points cross at the x-axis. Then you can have 2 additional points to guarantee that you're graphing this parabola accurately. Now we just looked at how to solve a quadratic function with 2 solutions. We're going to look at how to solve a quadratic function with 1 solution. So again, I'm going to rewrite this quadratic function as negative x squared plus 2x minus 1 equal to 0. And then I'm going to find the axis of symmetry. So it's at 1, x equal to 1. And then I'm going to let 0 here be y, and then I'm going to look for the vertex. So I'm going to substitute 1 in for x. So that would be at 0. So vertex will be 1, 0. And then we're going to look for the y-intercept. The y-intercept is at negative 1. I'm going to reflect this point. So So the reflecting point will be 2, -1. And then we can go ahead and draw a parabolic graph. Now, as you can see, this parabola only goes through the x-axis at one point, 1, 0. So this has to be your solution, x equal to 1. And when we factor this, we should get something similar, or the same. So x equals to 1, which is your solution. Now we're going to look at how to solve quadratic functions with no solutions. So let's first try to graph this. Okay, and let's find the axis of symmetry. So it's at 1/3. And now I'm going to rewrite this quadratic function as y equals 3x squared minus 2x plus 1. And now I will find the vertex. So the vertex will be at 1/3 and 2/3. And the y-intercept when x is 0 will be 1. So the y-intercept is at 0, 1, and reflecting point is at 2/3, 1. And we can plot this parabola. As you can see, this parabola does not cross the x-axis at any point. So we can conclude that there are no solutions for this quadratic function. So because this graph tells us that there are no solutions, we can just go ahead and write no real solutions to be more specific. There's no need to factor this anymore to check our zeros because there are no zeros, no real solutions for this quadratic function. And later I will teach you how to use a formula, which we call the quadratic formula, to be able to tell whether a quadratic function has 2 solutions, 1 solution, or no solution. So in this lesson, just focus on finding the solutions by using graphs. A quadratic equation here, let me give you a summary, has 2 solutions if the graph of its related function has 2 x-intercepts, meaning when y is 0. So these are your x-intercepts. And a quadratic equation has only 1 solution if the graph of its related function has 1 x-intercept. A quadratic equation has no real, now this word is crucial here, real solutions, because we can have imaginary numbers too. That will come in algebra 2. If the graph of its related function has no x-intercepts. here I'm going to show you how to approximate the zeros of a quadratic function. In other words, the solutions of the quadratic functions. So first I'm going to find the axis of symmetry, which is -2. And then I'm going to find the minimum value. So therefore, my vertex will be at -2, -3. And my y-intercept will be at 1, reflecting point at -4, 1. And I'm ready to draw my parabola. Okay, as you can see, your zeros do not intersect at an integer. So now we need to approximate this by using x values between -4 and 3 and -1 and 0. So I'm going to only show you how to do -4 and -3, and then you can do -1 and 0 yourself. So we're going to use an increment of 0.1. So I already know at -4 my y value will be 1. So I want to know what my y value, or what f of x would be when it's -3.9. So when I substitute -3.9 in for x, I should get about 0.61. Now I cannot just conclude that my 0 will be -3.9. I need to make sure that I find the 0 that is the function value closest to 0, so that I could get a good approximation of x. So when I substitute -3.8 in for x, I should get about 0.24. I'm going to keep going. -3.7, this would give me -0.11. And then when I substitute -3.6, I get a y value of -0.44. Okay, now I'm going to stop at the approximation of -0.44, because I notice that f of x of -0.44 is moving away from 0. And it seems like -0.11 is closer to 0. And 0.24 is also close to when x is 0. So, but between 0.24, let's draw a number line here. This were 1 and this were -1. 0.24 will probably be right here. -0.11 will be about here. So between -0.11 and 0.24, -0.11 is closer to when x is 0. So our approximation, the best approximation will be when the function value, f of x, closest to 0, would indicate that the x value of -3.7 would be the best approximation of this 0 function. So one of our zeros could be -3.7. And when you go to the other point, you need to do the same thing. And the approximation would be about -0.3. So your zeros, your best approximation of this f of x function will be at -3.7 and -0.3. Now, I'm not going to make you do a lot of these kinds of problems, but I would just like to give you an idea of how to approximate quadratic functions. Now let me give you a summary here of the terminology. When you're given a quadratic function, something negative x squared plus 8x minus 12 equal to 0, then we will be looking for the solutions of an equation. So I'm going to go ahead and factor this. And your solutions will be at x equals 2 and 6. And if we were given a quadratic equation in the form of y equals negative x squared plus 8x minus 12, then the values of x, meaning when they cross the x-axis, will be called x-intercepts of the graph. And you will write your solutions as coordinate points so that they could be read as x-intercepts. But when you're given a quadratic function or a quadratic equation in the form of f of x equals negative x squared plus 8x minus 12, then we will refer to the x values, meaning the values that cross the x-axis, as the zeros of the function. So I've been referring to all the values that cross the x-axis as the zeros. Okay, so meaning when f of x is 0, then what are your x values? So again, it will still be 2 and 6. So here I'm just telling you, when you're given a form of a quadratic equation, how would you refer to the solutions? So I guess these could all be considered synonyms, depending on the form of the given quadratic equation. Okay, let's practice solving some equations by graphing. In the first one, we're going to first look for the axis of symmetry. So it would be 2. And then we're going to look for the minimum value. So we have y equals 2 squared, which is 4, minus 4 times 2, 8, minus 12, negative 16. So our vertex will be at 2, negative 16. I'm going to plot that. And then I'm going to look for my y-intercept, which is at negative 12. Reflecting point, 4, negative 12. And then we can go ahead and plot this. Okay, as you can see, your parabola crosses the x-axis at x equals negative 2 and 6, and they should be your solutions, and you could factor to double check. So x equals negative 2 and 6. These are your solutions. And the next one, again, let's find the axis of symmetry. Negative 10 over 2 times 1. Negative 5. And then we're going to have to look for the minimum value. So we have sub this in, so 25, sub negative 5 in, minus 50 plus 25. So this would be negative 25 plus 25, 0. So your vertex will be at negative 5, 0. And then your x or y-intercept when x is 0 will be at 25. Reflecting point, -10, 25. Let's graph our parabola. So in this case, the graph or the parabola only intersects the x-axis at one point, so your solution will be -5. As you can, and then when you factor this to check, you'll notice that you only have one solution, -5. And if we look at this one, x squared plus 2 equal to 0. Now, okay, and then we find the axis of symmetry. So it's at x equal to 0. And when x equal to 0, our vertex will be at 0, 2. And the y-intercept here is also at 2. So as you can see that this parabola did not cross the x-axis, and therefore we can conclude that there are no solutions. No real solutions. Now let's find the zeros of the function by graphing. Let's find the vertex, or the axis of symmetry, excuse me. So half. And now let's find the minimum value. So your vertex will be at half, -9. And then your y-intercept will be at -8. That's when x is 0. Reflecting point, 1, -8. And then we can graph this. So you can see your parabola crosses at -1 and 2. Now let's double check by factoring. So we're going to let f of x equal to 0. Okay, now we can cancel or simplify this equation. Therefore, x we have -1 or 2. And these are your solutions. Okay, for this word problem, an athlete throws a shot put with an initial vertical velocity of 28 feet per second. The shot put leaves the athlete's hand from a height of 8 feet. So basically, a shot put is a very heavy ball, spherical ball, and it's a kind of track event where you have to throw that heavy ball as far as you can. And here it says, part A, or prints, write an equation that models the height in feet of the shot put as a function of time after it is thrown. So when it is thrown, it's also going to travel at in a parabolic path. So we need to use the vertical motion model. Okay, let's substitute in the initial vertical velocity of 28 feet per second and the initial height of 8 feet. And this will be the equation that models the situation here. So I drew a little picture here. So this is the heavy shot put ball. And then find the time that the shot put is in the air, meaning this entire time before it hits the ground. So basically, we want this to be when h is 0. I'm going to substitute h for 0 and look for the time. And I can first simplify this quadratic function. Okay, and then now I can factor. So I'm looking at 4 and 1, and 1 and -2, magic cross, -8, +1 makes -7, so I have 4t plus 1 and t minus 2. So 4t plus 1 equal to 0 will give me a negative time, so we just ignore this, and the other time will be 2, so 2 seconds. And this concludes the lesson.